So are you able to see this PPT?
Yes, sir.
Is it visible?
Yes, sir.
Yes, please.
Yes, sir.
Your voice is very low. Okay. Now tell me, is it visible? Okay. So one problem, all of you please write down this problem. Example 1. If C is the boundary of C is the boundary of the square with vertices at the point z is equal to 0, comma z is equal to 1, comma z is equal to 1 plus I, and z is equal to I. Show that integral over C 3z plus 1 dz is equal to 0. So this is what we want to show. So here, what is the Cauchy's integral theorem? All of you see, if f of z is analytic function in and on a closed curve C, and z0 is any point inside C, then integral over C z minus z0 dz is equal to pi I f of z0. This is the Cauchy's integral formula. Before that, yesterday we discussed the Cauchy's integral theorem also. This Cauchy's integral theorem, all of you see, if f of z is an analytic function, f of z is analytic function, f dash z is continuous, at each point with in and on a closed counter C, then integral over C f of z dz is equal to 0. This is a solution. So by this Cauchy's integral theorem, you see this problem. If C is the boundary of the square with the vertices, that means C is a closed counter. Definitely C is a closed counter, and we want to show integral over C 3z plus 1 dz is equal to 0. Here definitely this function, polynomial function, this function is an analytic function. Every polynomial function is analytic. Therefore here 3z plus 1 is the function, analytic function. This is already we proved in the previous classes. Okay, 3z plus 1 is analytic function. Okay, this is satisfies the CR equations. Okay, so now the question is 3z plus 1 is analytic function and 3z plus 1 is a differentiable function. Definitely, therefore it is analytic, we are telling. It is satisfying the CR equations. Therefore, we are telling that this function is analytic. And definitely this is the differentiable function means what? Definitely it is a continuous function. It is a continuous function. You see here, the question is f of z is analytic function and f dash z, that means this f of z is differentiability, and that differentiable function is continuous. Okay, definitely here also you see this function is an analytic function and the differentiability of this function is continuous. Definitely 3z plus 1 is 3 only. F dash z is 3 and 3 is a constant function, means it is a continuous function. Therefore this is satisfying the Cauchy's integral theorem. Therefore if the function is satisfies the Cauchy's integral theorem, integral over C 3 f of z dz is equal to 0. So without doing anything, just writing these brief statements, by that one we tell that this function is the solution of this function is 0 because this function is analytic function and this is the differentiability of the function is continuous. Okay, that is you write down. F of z is equal to 3z plus 1 is analytic everywhere and I will write here in particular on and within the simple counter, simple closed counter. Counter TOU, simple counter C. Okay, hence by Cauchy's theorem, it follows follows that integral over C f of z dz is equal to 0. That is integral over C 3z plus 1 dz is 0. This is the answer.
Completed.
Completed. Next question. If C is any simple closed curve, is any simple closed curve. C is any simple closed curve. Evaluate integral over C f of z dz. If f of z is number 1 cos 3z, number 2 e to the power of 2z, number 3 sin z, number 4 z square plus 8, number 5 sin 3z plus 8z cube. So what about the first one? Tell me the answer. What is integral over C? Cos 3z dz is equal to. చెప్పండమ్మా. What is integral over C cos 3z dz? If C is any simple closed curve. Anyone please? చెప్పాలి. What is the answer? Charan Kumar, tell me answer. Tell me the answer. Harika. Monica. చెప్పమ్మా హారిక. What is the integral over C cos 3z dz when C is a closed contour? Any simple closed contour C. So that is we consider within the C.
0, sir.
Correct. That's all. The answer is 0 because cos 3z is analytic function by Cauchy's integral theorem, and this is a continuous function. Integral over C cos 3z dz is 0. Since cos 3z is function and f dash z is continuous, therefore by Cauchy's integral theorem is 0. Similarly, all the above functions are analytic everywhere and by Cauchy's integral theorem, integral over C f of z dz is 0 for each one of the given fz's. I'll have to write down one problem.
Sir, sir. Completed.
Evaluate integral over C. That means this is a closed contour. This representation is a closed contour. z square plus 4 by z minus 3 dz, where C is first A. Mod z is equal to 5. B. Mod z is equal to 2. Taken in anti-clockwise or positive sense. Positive sense. Evaluate this, where C is a closed counter. That means closed counter. That C is given as mod z is equal to 5 or mod z is equal to 2. So mod z is equal to 5 is a closed circle equation, that is with the center 0, 0, 0. Okay. Mod z. So here I am writing mod z is equal to 5 implies it is a circle equation. This is the circle. This is a center. So the radius of the circle is here. This is 5. Okay. This point is 0, 0. 0, 0. This is okay. This is the closed counter we are considering. Mod z is equal to 5. So integral over C. So what is the C? C is a mod z is equal to 5. That is a circle with the center 0, 0 and radius 5. Now the question is, this is we want to do. So in the positive direction we consider, anti-clockwise direction means this is the way. This is the way we are considering the circle. Okay, how can we do this particular problem? All of you see, this is the Cauchy's integral formula. So what it is showing, if f of z is analytic function in and on a closed curve C, okay, and z0 is any point inside C, a closed curve C we are considering, and this z0 is a point inside C, then integral over C f of z by z minus z0 dz is equal to 2 pi I f of z0. This is the answer. 2 pi I into f of z0. This is the Cauchy's integral formula. Here z minus z0. You see that this z0 value we are considering. This z0 definitely lie inside in and on a closed curve C. Then only. If this z0 lie outside the circle, then here I given the one note. If no such z0 inside C, the integration of the function is 0. Okay, so therefore integral over C f of z by z minus z0 dz is equal to 2 pi I f of z0. So this is the formula I am using, and z0 value we are taking inside C, inside the closed curve C. Okay, so here you see the problem. Integral over C z square plus 4 by, sir na voice bagu sanga sir, z square plus 4 by z minus 3 dz, where c is mod z is equal to 5. So now mod z, this is the contour we are taking, closed contour, closed curve we are taking. Okay, here in this closed curve, you see where is z naught. So here I am writing the solution. First A I am taking mod z is equal to 5 is the circle with the center 0, 0 and radius 5. Radius 5. Okay. First, given function is analytic function or not. First, that is we want to check. Here you see that z is analytic function. F of z is analytic function. Okay. So therefore, we want to check the function is analytic or not. Definitely, z square plus 4 is a polynomial function, differentiable everywhere, and also it is satisfying the CR equations. Therefore, it is an analytic function. Simply. Okay. So therefore, z square plus 4 given function is analytic everywhere, but you see that this function is everywhere, but at z is equal to 3 you substitute, definitely 3 minus 3 is 0, you are getting here a singular point you are getting. So therefore at z is equal to 3 it is not analytic function everywhere except z is equal to 3. Z square plus 4 by z minus 3, the function we are considering analytic everywhere except z is equal to 3. And it is lies inside C. That is z naught is equal to how much? Z minus z naught. Z minus z naught. Z minus z naught. Z naught is 3. You see that this 3 z naught where it is lying. This is the closed contour, closed curve. This is a circle equation and a circle with center 0, 0 and radius 5. So then the function, if we consider this function where z naught value, you see that this z naught is equal to 3 means what? This is 1, 2, 3, 4, 5. So that means here it is lying. Here it is lying. Z naught is inside C. Simply Z naught is inside. Z naught is 3. Therefore, this is inside the circle. So therefore, integral over C z square plus 4 by z minus 3 dz, I will write as integral C f of z by z minus z naught dz. Okay, where f of z is z square plus 4 and Z naught is 3 and C is mod Z is equal to 5. Okay, so using Cauchy's integral formula, integral over C f of Z by Z minus Z naught dz is equal to 2 pi I into f of Z. So this is equal to this means our function I am writing integral over C f of Z is what? Z square plus 4 by Z minus Z naught dz is equal to 2 pi I. Here Z minus 3, Z naught is 3. Two pi I f of
3.
F of here I am writing f of Z is given that Z square plus 4. That means f of 3 is f of 3 I will write here.
F of Z naught is equals to 3, sir.
F of 3 it is 3 square plus 4 that is 9, 10, 11, 12. ఎంత అవుతుంది 9 plus 4 10 13.
13.
Okay, so this is equal to 2 pi I into 13. So this is equal to 13 to 26. I will write like this 26 pi I is the answer.
Completed.
Okay, the next one is B we want to do here that is given mod Z is equal to 2.
2.
Mod Z is equal to 2. This is the circle with the center at 0, 0 and radius radius is 2. So that is, you see the circle I am drawing. This is 1, 2, 3, 4 point list. 1, 2, 3, 4 point list. ఇప్పుడు మనం ఇక్కడ నుంచి ఇలా వస్తుంది. With center 2, the center 0 and radius 2. So this is 2. Okay, radius equal to 2, but our point z0 is equal to 3 is the point lies outside the circle mod z is equal to 2. అంతే కదా, అవుట్ సైడ్ ది సర్కిల్. ఇది 3. పాయింట్ 3 ఈజ్ ఇక్కడ ఉన్నది, మన పాయింట్ 3 ఈజ్ ఇక్కడ ఉన్నది. ఓకే, కానీ రేడియస్ 2, ఇది అవుట్ సైడ్ ది సర్కిల్. బట్ ఎఫ్ ఆఫ్ జెడ్ ఈజ్ ద ఫంక్షన్, బట్ ఎఫ్ ఆఫ్ జెడ్ ఈజ్ analytic function on and in on and within, I will write, or in C, analytic function. If suppose you take the function, the function is analytic function inside the circle. So by the note, you see here I given the note previously. If there is no such z0, f of z is analytic function. If f of z is analytic function, if there is no such z0 inside C, and C is a closed curve, and this z0 is inside C, there is no such z0 inside C, then the integration of the function is 0. Then the integration of the function is 0. ఇక్కడ ఏమైంది, the function is the analytic function, but mod z is equal to 2 is the circle with center 0, 0 and radius 2, and our point z0 is equal to 3 is the point outside lying the circle. So therefore there is no such z0 inside C. Therefore the integration of the given function value is 0. Okay, hence by Cauchy's integral formula, integral over C z square plus 4 by z minus 3 dz is equal to 0. This is the answer.
Completed.
Oh. Next, all of you write down one more problem. Let C C denote the boundary of the square whose sides lie along the lines x is equal to plus or minus 2, y is equal to plus or minus 2, where C is in the positive sense. Then evaluate each of the following Okay. Integral over C e to the power of minus z by z minus pi I by 2 dz. Number 2, integral over C cos hz by z power 4 dz. The first one is the previous one. How we do the previous one? The same way we do this problem. Okay, first I will do the second one. Solution number 2. First I am doing. Let us first draw. Let us first draw the counter. CON DOUR. Counter C. So here you see that this is the x-axis, this is the y-axis. This is 1, 2, and 2 only. We have the maximum 1, 2, 1, 2, 1, 2. X is equal to plus or minus 2, means these two. These two. Okay, so that means in the direction of lines and anti-clockwise direction, positive sense. Okay, closure counter. So here the representation is the line. This is I will take A, B, C, D. So then the lines AB, DC are y is equal to plus or minus 2, minus or plus 2. First minus, after that 2. Otherwise you write down. No confusion. Y is equal to AB is minus 2. This is 2. Minus 2. Comma y is equal to 2. Respect. And the lines BCAD are x is equal to 2, comma x is equal to minus 2. Respectively. So the second question is what? We want to show that integral over C cos hz by z power 4 dz is how much, the value. So here you see I will take cos z by z power 4 is given. Okay, this is equal to, can I write like this one, cos z by z minus 0 whole to the power of 4. This has z naught is equal to 0 as a singular point. a singular.
సార్
Yes, చెప్పండి.
ఇక్కడ కాస్ హెచ్జెడ్ సార్, కాస్ హెచ్జెడ్.
కాస్ హెచ్జెడ్ రాసింది. Cos hz. Okay, so z naught is equal to 0 as a singular point, which is, so definitely this 0, z naught is equal to 0. Where z naught is equal to 0? This is the z naught is equal to 0. You see that these are the points. This is a z is equal to 1, z is equal to 2, z is equal to -1, z is equal to -2, z is equal to 1i, this is a 2i, this is -1i, -2i, z value, this is okay. Z naught value here, z naught is equal to 0, it is lying inside the contact, definitely. So singular point, and it lies inside C. Okay, and we choose f of z is equal to what? Cos hz. So now we apply the Cauchy's integral formula. We know that integral over C f of z by z minus z naught whole to the power of n plus 1 is equal to, so what is the answer? You see here, you see z minus z naught whole to the power of n plus 1 dz is equal to 2 pi I by n factorial into the nth derivative of f of z naught. N is equal to 1, 2, 3. So this is the answer. చెప్పండమ్మా, చెప్పమ్మా. Any doubt? Okay, f of z integral over C f of z by z minus z naught whole to the power of n plus 1 is equal to 2 pi I by n factorial into the nth derivative of f of z naught, where n is equal to 1, 2, 3 and so on. So here our problem is like this one. So this is, I will write as integral over C cos hz by z power 4 dz. I will write as integral over cos hz by z minus 0 whole to the power of 3 plus 1 dz. I will write like this: 3 plus 1, 3z, and this is equal to 2 pi I by n factorial is 3 factorial, the third derivative of f of 0. This is the answer. So here we want to find f of z is given as cos hz. This implies f dash z is sin hz, and this implies f double dash z is cos hz, cos hz. This implies f triple dash z is sin hz. Okay, sin hz. So therefore integral over c cos hz by z power z minus 0 whole to the power of 3 plus 1 dz is equal to 2 pi I by 3 factorial is 3 factorial only you write down into the third derivative of f of x is this is the third derivative. Directly I will write this value is, otherwise one more step I will write, f of third derivative of 0 is equal to 2 pi I by 3 factorial into sin h z z naught we take. This is equal to 2 pi I by 3 factorial into sin h. Sin h 0 is 0. This is equal to 0 is the answer. Finally, it is a 0. The answer is 0. So problem A is a homework you do. Homework it is.
Completed.
So these are the problems we discuss in this class. And in the next class tomorrow, I will discuss about the some more problems on this one, and after that I will go for the Taylor's and the Maclaurin series for complex variables. Okay, so after that residues, by that one I will conclude the 5th chapter. Any doubts, anything you want to ask, please.